So far, we've discussed Q equals mc delta T, where Q is the amount of heat that is gained or lost in a chemical reaction. Okay, and when Q is a positive value, that means that heat is being absorbed, and that represents an endothermic process. When Q is a negative value, heat is being released, and we call that an exothermic process. Okay, in today's video, we're going to kind of take that information we've learned about Q and relate it to the amount of heat that is gained or lost per mole. And when you talk about the amount of heat that is gained or lost per mole, or the amount of energy that's gained or lost per mole, that is referred to as the enthalpy. Okay, and the symbol for enthalpy is the letter H, and you will see this a lot. Delta H with a little triangle in the front, meaning delta, meaning the change in the enthalpy, how much heat is gained or lost in a chemical reaction. So when you calculate Q, Q is just measured in kilojoules or joules. Delta H is measured in kilojoules or joules per mole. Okay, and so in this example, example number 1 here, in a chemical reaction, 2.5 grams of propane releases 425 kilojoules of heat. What is the value of Q for this reaction? So it's releasing 425 kilojoules of heat. That means Q equals negative 425 kilojoules. Nothing special that you need to do there. Okay, calculate the value of delta H, though, is the amount of heat released per mole of propane. Well, we don't have a mole of propane. We have 2.5 grams of propane. So how many moles of propane is that? Well, we've got to convert our grams to moles. So the molar mass of propane is 44. So I'm going to take 2.5 and I'm going to divide by 44. And that's going to get me 0.0568 moles. And now I'm going to take my 425 kilojoules and I'm going to divide by that. Because remember, enthalpy is the amount of heat released or absorbed per mole. Well, again, if this releases this much heat and that's all the propane that you used, that's not very much propane. So if you were to use a mole of propane, we've got to take 425 and divide by that answer, and that equals 7,480 kilojoules per mole. And again, we're still going to have a negative there because it's releasing heat. Now, on the AP tests, many times what they'll use when they're talking about enthalpy is they don't just call it kilojoules per mole like I did here. They're going to call it kilojoules per mole of reaction. Okay, and this is something kind of new. You can see it down here as well. Okay, and really what that means is it really means this step right here. Okay, here's the balance equation right here. And basically when they say moles of reaction, it means if this reaction happens 1 mole of times, then this is how much heat is going to be released. And if that happens 1 mole of times, so if it happens 6.02 times 10 to the 23rd times, then 1 mole of nitrogen, 3 moles of fluorine, and 2 moles of NF3 are going to react. So what you've got to do is this step right here is notice that when you're using a balanced equation that I have to convert from moles of whatever they're asking me about to moles of reaction. Okay? And when you do that, now that means that when this reaction happens right here, when 264 kilojoules of heat are released per mole, well, how many moles? 1 mole of nitrogen, 3 of F2, or 2 or NF3. It depends on what information they give you. Since they're giving you information about F2, then you've got to convert from moles of F2 to moles of the reaction using basically 3 F2s in 1 mole of the reaction. Okay? Now, anytime they ask you a question, at the end you should always decide, even like I did up here. Notice that when I did this problem right here, I didn't put the negative sign in there. I waited until the end. Okay, with positive and negative signs, you have to read the problem and make sure that you're answering it correctly. For example, here they're saying that heat is released. Okay, if they're saying that, you can't release a negative amount of heat. So anytime they say, hey, look, we know it's exothermic, it's releasing heat, you don't need to put a negative answer. We know that it is, that delta H is a negative value. We saw that up here. So when they say heat is released, that value is always going to be a positive sign. Okay, let's look at one more, and then I'll do another video with some different examples. So the enthalpy of reaction when NaN3 decomposes at 298 is shown below. A student claims that when 1 mole of NaN3 is decomposed completely, 21 kilojoules of energy is released into the surroundings. Do you agree or disagree with the student's claim? Justify your answer. Okay, so when 1 mole of NaN3, so let's just do the math here. 1 mole of NaN3. Okay, in this case, they didn't give us grams, so we don't have to convert grams to moles, first of all. So that up here we did. Notice my first step was to convert those grams to moles, but since we're already at moles, then we're fine. So now we're going to go based on our balanced equation. If this equation happens, this reaction happens a mole of times, we're going to say that 2 moles of NaN3 are going to react for every 1 mole of that reaction occurring. Okay, and then we can say, because remember, these units are moles per reaction, every 1 mole of reaction, we've got 42 kilojoules. And again, notice I left out the negative sign there. 42 divided by 2 is 21 kilojoules. So do we agree or disagree? Absolutely, we agree. And then again, if to justify, we did just justify using math, but you could say something about for every 2 moles of NaN3, in every 1 mole of reaction is going to produce 21 kilojoules of heat.